Hi there, I'm Kyle with iFixit, and I am here with Jessa Jones from iPad Rehab. And we have been working on a series where we're teaching you how to do microsoldering. So this is repairing things at the extraordinarily tiny level. So not just swapping out a display, but actually repairing individual components on a board.
Yep.
And in the last video, we showed you how to, or I was able to, for the first time ever, to do a repair on an iPad mini. So I was able to replace a little tiny
That was
component.
an incredible repair. It really was.
So that was exciting. So now I'm totally jazzed, and I want to fix everything. And so we've been going around the office looking for things to fix. And this is an iPhone 4S that one of our staff had. He used it for a long time. It stopped working. He tried fixing it by replacing the battery, replacing some other things. Was never able to get it to work. If you put a charged battery in here, it works fine, but it's not charging the battery. Is that right?
Close. Let's grab that charger that's next to you, and we can kind of show you what happens with this. So this phone I thought was a good candidate for repair because it was we wanted to use it for a video later on, and we were finding that
so it powers on fine.
It would boot up and work. You know, it'll come to full display there as long as the charger is connected. But if you disconnect the charger, the phone should then switch to battery power and stay on, but it doesn't. It just sort of clicks off right away.
So this is the sort of infuriating thing where you're like, it almost works. The phone is fine. There's just one little thing.
Right.
And this, so we're going to talk general troubleshooting techniques.
Yes.
How do you go from, I know I have a problem, but I have no idea where to start.
Right.
And these sorts of troubleshooting techniques are generic to any kind of electronic board repair you're getting into.
Exactly. So there's a few things that I just sort of want to cover about general troubleshooting, and this is just a good example to use to kind of cover those things. So the first thing is, to kind of get a history of the problem and sort of figure out where you're going to start thinking about this. We want to sort of apply a thoughtful approach and get away from just sort of like, randomly trying things without really, a whole lot of specific intent. So description of the problem. So we know what's going on with this. We know that it has a history of a prior repair attempt. So that's really going to guide our thinking.
Somebody started doing repairs on
Right.
this.
So what kind of things is that going to make us start thinking about? Physical damage on the board.
Right.
Maybe.
So it could be while he was swapping something in, he damaged something on
Exactly. And that's really common. These things are tiny, as you know.
Right.
The connector or something like that could easily get mangled, something like that. The other thing is, does it have a history of water damage? And this one does not.
Okay.
And does it have a history of a really bad drop? Because all of those things sort of point your thinking a little bit differently. We talked earlier in another video, bad drop means
that it could be a Bga
exactly
chip
that you could have and that's going to be invisible damage.
And the Bga chips, these are the large ICs, so the big big
black squares.
Those are attached to the board with a ball grid array, a grid of solder balls,
right.
And the solder balls can crack.
Yeah, or the connection between the board and the balls, or the chip and the balls. Right. So that can crack. And what is that going to look like on the board? Nothing. So that's a rabbit hole, So there's, the other thing that I want to kind of point out is that not all problems are solvable because of chip density. So sometimes in the iPhone, like if you look at this bare board, there's like so many chips that will ultimately go on there that we don't have the clearance that we need to be able to replace all of them. Some of them we're not going to be able to source, so we're not going to be able, even if we know what's going on.
If the main processor is dead, the whole board is dead.
That's really not worth it. Exactly. So certain repairs are just not feasible. The board may not be worth the time that it would take to troubleshoot, to source it, to develop the technique to replace that chip. Those sorts of things. Right. Especially in iPhones with the underfill. Underfill is like a big plague for us, and I'm sure that we'll kind of get a systematic solution to that one day, but right now it's still sort of picking away at that stuff, which, surrounds and cures those Bga chips to the board.
So this is where the answers forum has been really helpful because it's a troubleshooting forum, and I know a lot of the questions that we all get the most excited about are the ones where you're playing Dr. House a little bit. You're diving in. We're diagnosticians with these things.
Right. And that is sort of the next key, that, you want to kind of develop a sort of physician-like mindset, a phone physician, where you can kind of get an experience base of what are the common failure points for each device, and to sort of help that guide you in your overall goal of avoiding rabbit holes, which is those projects where you're going to ultimately sink a ton of time into it and not be successful.
Spend days and days and days trying to fix something.
Right, exactly. So this phone, really jumped out at me because it has a standard pattern. So in the iPhone 4S, should be able to boot off of the charger without the battery, and it does.
The moment I disconnect the charger, it loses power.
Exactly.
Okay.
And the iPhone 5, 5S, 6, they cannot boot off of the charger without the battery. They require the battery. Okay. So these sort of little differences and things that you kind of just sort of put together and learn. So because this one is able to come to a full display and boot up fine, but the moment you disconnect the charger, that points to a classic problem with the iPhone 4S. And it has a weak point at the battery connector itself.
All right, so we're going to unplug it.
Yep. All right, so now that we know that this, at least it fits a pattern of common failures. So now we're going to kind of dig into that. Okay. And you're going to look at the battery connector itself. Let's take the battery out first and measure it.
Okay. Sounds good. So I've got the battery, and this has been removed before, so there's not as much adhesive on it.
Right, so
we've got the battery. We have our voltmeter here.
Yes.
And I'm setting the voltmeter just to the 20 volt range. We know this is. And by the way, a lot of your multimeters are going to have, the tip is too big to get into things. So you soldered on some additional fine needle points. All right, so are we reading anything?
0.01. So the battery is absolutely definitely dead. So in an iPhone, the battery needs to be 3.8 in order to turn the phone on. If the battery is something like 3.5 volts or something like that, then you'll get like a low battery icon and it will prompt you to charge it back up. If the battery is fully charged, like 100%, it'll read like 4.1 volts, something like that. If a battery is like 2 volts, 2.96 or something, it may not even have enough juice to turn on the low battery icon. So a 0.00 volts is a stone dead, flat dead battery.
So the phone sucked all the juice, didn't feed any more back into it.
Exactly.
So we know that the charging circuit on the phone is just not functional. Right? Or the battery can't talk to the phone at all.
Well, I mean, there's a lot of when you see a battery that's that dead, here's what you can think. One, it's just really old and it didn't hold its charge at all. I mean, this could be this is a 4S. This could be years old.
Right.
Number two is that the phone could have a short in it that has drained the battery below what it would normally kind of stop at. And the other would be a boot loop, and that would be my guess in this phone, where if a phone continues to try to boot, then it will just sap a low battery to like a stone dead battery.
Okay.
So that's what you're thinking when you have a stone dead battery, and all of that is part of troubleshooting. Okay. So now we know a little bit about the battery. Let's look at the battery connector.
All right. So this is the connector.
All right. Does that look factory or prior repair attempt?
This looks like it's been manipulated by somebody. This looks pretty torn
Apple
up.
does a far better job of soldering than that.
Okay.
So now we really want to see whether or not that battery connector is good. So one way we could do it is to sort of test with a multimeter for continuity. And that's something we didn't talk about before, where continuity is just sort of measuring, does point A and B that are in the same circuit actually connect? Or
continuity is my favorite tool on here because it's easiest to use. I just touch things together and it beeps if you have a wire contact.
Exactly.
I love this test.
Yes. So and I use it a lot as well. I mean, you can also kind of get away with it by sort of measuring resistance to ground, but just hearing that beep allows you to very quickly kind of move around and see what's going on.
Got it.
So, okay. So you could kind of, look up on the schematic and figure out like where should the power pin talk to, where should the ground pin talk to. Let's see if the ground pin talks to ground. So you can measure that by putting one of those probes, and it really doesn't matter red or black, on any part of the frame. So that's ground.
Vibrator shield. So I'm getting nothing there. We'll just check this one for posterity. So I'm getting nothing.
As you're touching that, do you feel movement in that connector?
Yeah, look at that.
Yeah, I mean that's like
so
clearly not
is very poorly attached.
Yeah, look at the the one pin.
So this is clearly, you can see the solder moving. So this is the solder is broken. Look at that.
Yeah, that's nuts.
This pin is just not attached.
Right. So
okay.
there ain't no way that if you plugged a battery in there, that battery is going to
And so as I look at this, with my naked eye, I can see a little bit, maybe, if I know what I'm looking for. But once you throw it under the microscope, you can really see the movement much, much more clearly.
Yes.
And by the way, going into this, we had no idea that this was the problem. We were just given this phone, told somebody had tried to fix it. We didn't know how or why.
Right.
So this is our initial diagnosis is that we need to fix.
Right. Well, and that's part of like kind of pattern recognition with phones. You know, that that's a common problem. You know, the iPhone 4S battery connector pops off all the time. You know, so just sort of knowing these sort of little failure points in every phone, just like 5S gets blue screen from the long trace damage, you know, that iPhone 4S gets grayed out Wi-Fi. You know,
and you can tell that a lot by just looking at the repair manual on iFixit and seeing what people are talking about. People are talking about the battery connector falling off. And you can look at the comments at the bottom of the guide. You can also look in answers for your device and kind of get a feel for what so you don't have to have a repair shop where you're getting lots and lots of experience. You can kind of infer from the wisdom of the crowd what common problems are.
That's true.
So iPhone battery connector, plastic connector, maybe it could have been connected a bit better from the factory, breaks a lot during repairs.
It does.
So this is not a surprise that we got.
So this is like, you know, that one of the first things that you would be thinking of as phone physician. You know, I'm in a dead battery situation. Now, while we're talking about this sort of, you know, specifically, the battery, this is very common for all phones as well, generically. Those 4 pins are present in all of the, you know, all the devices. Because all devices need to get the same information from the battery. Right. You know, which is, you know, how much charge is there left so that it can sort of govern the charging cycle. And then it needs to know the battery temperature. And especially the battery temperature. If it can't get the battery temperature, because let's say that line is broken, either the connector's wrong, some little component in that line is knocked off, which is also very common with fingernail damage, connecting batteries, then the logic board will just say, I'm not going to, you know, allow this to blow up. If you can't tell me what temperature you are, we're shutting this whole show down. And that happens a lot. And that'll come up as a boot loop, you know, where the you know, the phone just sort of freaks out. It starts to turn on,
it gets to the place where it's going to read the battery temperature, it freaks out.
Yeah, and you can get a lot of information also from the log. So if you plug that into iTunes, or not iTunes, but if you plug it into some sort of like third-party, you know, reader like iBackupBot I use a lot, you can sort of read the real-time logs where it will sort of give you a real-time status update, things that's going on inside the phone, and you'll start to see errors. Gas gauge error, cannot get temperature for gas, cannot get temperature, cannot get gas gauge, and then it'll just shut off, and then you know, let me take a hard look at my connector around the area, or sometimes that's how defective batteries are. Like inside the battery itself, you know, if you that
or
little
maybe
tiny
in shipping
line,
the connector got damaged.
Right, yeah. So that's like another sort of failure would be the battery itself. So replacing the battery would be a good step one as well.
Okay. So should we fix this?
Yes. So let's fix this. So this thing needs a new connector, or we could try to kind of solder that connector, you know, back down there. I think I have a new connector here.
Okay. So we've got a new connector. So that's probably going to be easiest is just to desolder that and put a new connector on.
Right.
So we've got our connector here.
Yep.
And it just, particularly the left side of that, just looks demolished.
Right. So that thing is attached by those 4 pins plus 2 anchor pads that are sort of less important. And the anchor pads are on the back of the connector. The anchor pads don't do anything electrically. They're just there to sort of help stick that connector on there.
All right. So this is the new connector we're going to put on. And we have... Here we've got these 4, so those are our 4 connectors. And then on either side, on the back of the connector, we've got a pad.
Right.
Okay, and so that's not electrically significant.
Right, so those are really difficult to solder because they're enmeshed in plastic. So that is sort of difficult to solder. It's not an unreasonable strategy to say, I'm going to go for a good solid attachment on the 4 pins, and then I'm going to use like a tiny toothpick dab of an adhesive to secure the bottom of the connector.
We've got the connector under the microscope here, and as we're looking at it, you can see underneath we have these resistors here, and these traces are going underneath the board, probably going to the gas and temperature gauge sensors here. So if you put the connector on wrong, it's very possible to damage these traces on the board.
Now, of those 4 components that are right there, the schematic tells us that 2 of them are resistors, 2 of them are capacitors. And a capacitor and a resistor does, really different things. And that's also part of just kind of general troubleshooting, is learning to recognize those components. Just from experience, I can look at that and see that the capacitors are a little bit more squarish in shape, and the resistors are a little bit more rounded.
Okay, so you're saying
in that set of 4. Yeah, those 2 are capacitors. That's capacitor.
Those are capacitors, capacitor.
Yes.
These are resistors.
Yes.
And that's a capacitor on the
Yes,
side.
exactly. So if you think about what a capacitor does, a capacitor has one side connected to ground and the other side connected to the line, usually in most cases. So what would happen if I were to say, oh, I know you need to sort of, jump one of these. It's gone. I'm just going to jump it. Then what's going to be the consequence for the phone if I jump a capacitor?
If you skip a capacitor, it's bad news because you'll short out the line and...
Right, yeah. If I connect a capacitor which has one side on ground and the other side connected to the line, and I connect that with a wire, I've shorted the line to ground. Right. So and that's a bad idea. You shorted out the phone. It's never, that's bad. However...
These others, so we pulled up the schematic, and we are not able to show you the schematic in this video. I'll explain why in a second. But we pulled up the schematic, and we looked up the value of these 2 resistors. Yep. And it turns out that they are 0 ohm resistors.
Right. Yep. So a 0 ohm resistor, if we're measuring resistance, 0, that's none. So really, they are just like they are, in fact, jumpers. You know, they're just their placeholders to sort of, bridge those 2 pads in order to allow flow through the line.
Okay, so we've identified. Now, we don't think we're going to have to replace any of those components, but it's helpful to know.
Hopefully, you're not going to float them off, so
okay.
No pressure.
So I'm looking at this, and just by wiggling the board a little bit, it sure seems like the center 2 pins are attached, and the 2 outside pins are really not.
Right.
So
if you want to, we can just sort of try to reflow those two onto the pad. Probably it would be best to just replace this connector.
Okay. So let's just go ahead and replace the connector.
Okay. Now let me ask you a question before we start about thermal mass. When we're trying to make joints and we're going to apply heat to, flow solder with flux, then the amount of heat that you need to apply to those 4 joints is going to be different. Which one's going to take the least amount of heat?
The joints that are going to take the least heat are the ones that aren't attached to the board.
Well, so let's think about the actual trace in the board.
Okay.
So we
know the trace on the boards for the ground and the
So we know
voltage.
one is ground, one is power.
Right.
And then one is gas gauge and one is temperature.
Right. So the center 2 aren't going to be attached to lines that are as large.
They're going to have a little tiny line, like a thin wire in the board. So continuing from the battery straight, on through the board to the power chip or wherever they're going, that's a thin line. So the amount of thermal mass, the amount of heat that line is going to require in order to flow that joint is going to be relatively low.
Okay.
And that's a common problem here when you are, this is like a great place to start learning to solder. These are pretty big. You'll find it easy to flow the 2 center joints, but hard on the 2 outside ones because of thermal mass.
Because it's going to take more temperature to heat them.
Yes.
Okay. And now in terms of making sure that I'm not heating this too much so I don't heat other components, it's just like the moment I can get it free, I want to pull it loose? How do I make sure that I'm not applying too much?
That's a really good question. So what's the downside of kind of a mindset of, I don't want to put too much heat on this board, so the second I can, I'm going to rip it off? What's the downside?
You can pull a pad off.
Yes, pulling off a pad. And that does happen. And the reason why is, again, with this thermal mass. You'll see that the 2 center ones will quickly will become liquid. You'll be like, I'm ready. I'm going. I'm taking it off. Yeah. And the 2 outside ones are going to rip off. Okay. So you really kind of want to err on the side of, getting them sort of
getting
loose.
them all loose.
Right.
Okay.
Now, how could you help yourself out to sort of reduce the amount of heat that was required? Like this, that's kind of a tough question, but when we need to sort of flow a joint, we can either increase the temperature here, or
increase surface area.
Yep, you could sort of put the 2 tips together, for example.
Okay.
Or you could use a bigger tip, like we have a couple, like a monster tip like that. Or you could, reduce the amount of heat required by making an alloy.
Okay.
So if you mixed in something that had a low melt. Yeah, exactly. Now, what do you know about this solder most likely since it's a prior repair attempt?
So this is probably leaded solder.
Right.
So it's probably going to melt.
Come off. Yep.
So, all right.
Now, flux. Add more flux.
Okay, so I need to add flux to the
Yes.
system. So we have our flux gun, our
Yep.
flux syringe here. Okay, so we're going to flux all around.
Now let me make another point here, because this is the 4S and I've learned this the hard way.
Okay.
You are working on top of the screen right now.
Okay.
So, we could take this board out to do the repair. And if you're careful, you can work on it in sort of,
C2.
that's what I say too.
Yeah.
No, I say that all the time.
All
Like,
right.
So yes, we're gonna do that, but just
So
sort
that
of
just
be
means I want to
mindful.
minimize the amount of flux that I get on.
You want to be mindful that if you get a drop of flux or alcohol that goes down off of this board, it's going to be dropping onto the backlight pages, and then you'll have a white spot on your screen.
Okay, so we'll be very careful with the amount of flux. I've got flux on all of the joints. And now...
Yep. So if you're doing this at home, you might want to take the board out if you're planning to save this phone and use this phone and don't want to replace the screen, so that you don't get a drop on the backlight. You're drifting out of the...
Okay.
Okay, good.
All right, well, that was a bit harder than I was expecting it to be, because I kept moving from one connector to the next, and I'd get it loose, and I'd go to the next one, and it would...
Right.
Okay.
So, if you use the quick alloy, that's a good way to kind of make it easier on yourself.
So I can modify the melting point of the solder that's there.
You could kind of make them all really flowy, so that you just sort of like go back and forth, and the whole thing would come off.
And you can see I mangled this connector pretty good. This is the connector that I took off, and it's pretty toast at this point.
Yep.
Okay.
So now we want to tin your pads. So we're going to braid, and then to kind of clean them up. We don't really know what's on there, so you're going to kind of get them back to the basics.
All right. So I'm going to use a solder braid to suck up the solder that's on here.
Yep. So use flux, more flux with that, and then you're going to use, you're going to put some heat on that copper with flux, and
So put the flux on the copper itself,
or
on
the board. It doesn't matter.
Well, we're trying to keep flux off of the board, so I'll put it on here.
All right.
And got it there, and now we're going to... Okay.
That's good. You can kind of like rock it back and forth. So I think that this repair as well is a really great place to start, because it sort of, there's only 4 pads, they're relatively big, and it really sort of introduces you to this concept of thermal mass.
Sure.
And that, that you really have to just sort of have a feel and pay attention to how the board is responding. And you can't just predict that like every pad is the same. So, if I flow one pad, the next one's going to be exactly the same.
So as I'm working my way along, I am able to use the flux a bit as a paintbrush to kind of work my way through. And it's interesting, it kind of keeps soldering itself down, and then I heat it up and it desolders. And I'm just cleaning this up, and I'm trying to make them look square and happy. And it's just a little bit of a repetitive, just like cleaning a counter or something, but it's just much, much smaller.
So that one pad, that's the ground, and we remember from looking at the battery, it's a giant highway of copper, that's sucking your heat away from your joint, and therefore...
So that's why this is taking the longest.
Yeah, it's all muddy looking, and and that's tough.
So I have been trying to get this pad clean, and it just won't come clean.
So I'm going to give you a tiny.
Why don't we use the leaded solder?
Okay.
Because that's something that more people will have. I think
Okay.
that this is a bismuth alloy solder that's designed for this sort of thing, but I just don't think very many people are going to have access to it. So I want to try it using something that's a bit more common.
That's
so this
reasonable.
is just normal solder. And can I put a bit of flux on the solder itself, or do I need to put it on the pad here? Put the solder on the pad, or the flux on the pad?
Yeah, the pad would be good. So if you've been struggling with something for a while, then you want to kind of look back at your tips. Take a look at them before, have they gotten just all crusty and oxidized as you've been sort of like, kind of working on something, or are they okay?
I think they're okay.
Okay. And then you want to, check, like, is my flux all completely dried to a crisp and horrifying? So kind of keep that in mind as something sort of begins to feel a bit like worked on. All right,
Okay.
so there you go.
So I added a bit more
Yep.
solder to it. Now I'm going to clean the solder off my tip. But we'll
give it a shot here.
give this one more shot.
Yep. And with the mini tweezers, putting the two together gives you that extra heat.
So I've got my braid on here, and I've replaced it with the new solder. And let's see how good a job I'm doing.
So that's a lot better.
That's looking quite a bit better.
There. We need to, I think you want to clean that flux off, because that's pretty gummy for making a nice new joint.
Okay, so I have our bottle of isopropyl alcohol here.
Now be careful with that. So we definitely want to
why
put
don't I
that
put that on a Q-tip?
Yes. You
Okay.
can see that.
Look at that. That's
So
great.
those look good. So now you're ready to tin your pads. And the goal is that when we do place the new connector, you're just going to flow the pre-tin pads onto the connector.
Okay.
Now, the thing that you want to keep in mind is that you like them to all be relatively even. Because flux is, the purpose is to kind of keep, as you're putting that heat there, to prevent that, quick oxidation and get everything evenly liquid and then make a nice joint.
So how do I get the solder to go down onto the pad?
That's a good question. One strategy is to, you can kind of like file your tips. If you put those two tips together, you'll create more heat at the bottom. You can do that, touch the pad and then feed the solder into it. That's good. There you go. And that one's going to take kind of more
Took
heat.
a little bit longer, but
Yep.
it worked. Okay,
Okay.
so we've kind of learned that the left pad there is the ground.
Yes.
It takes longer to heat up, but
Right.
that's okay. I was expecting it. It didn't take that much longer. Okay.
Now those would you describe those as sort of flat and beaded, or
No,
like mountains?
No, the right ones are. All right,
The Rocky Mountains and the Appalachians there.
so
So
try the.
yeah, so you want to try to just sort of, flow them, to a nice little rounded pad. If you kind of like swipe across it, there you go. Yes,
How's that?
that's good. So now let's place the new connector.
We got the new connector on tweezers.
Yep. Once you get the connector placed, we gotta move it up. Then you'll want to sort of put the tweezers on pins 2 and 3 and just kind of hold it there so that you can kind of come along and solder.
A lot of this is learning hand-eye coordination with
Yes.
both of these tweezers in this place.
Right. So you're going to want to apply downward pressure as you're soldering. So I would recommend turning that so that it fits your hand really comfortably, and then grabbing from the inside of the connector pins 2 and 3, and then kind of holding them with downward pressure. And you can use the other tweezers to kind of help get it exactly where you want.
So about there.
Okay, and then you can kind of continue holding that. And then with your right hand, you can,
Use this.
yep, you can try that. First tin it, so touch it to the solder with the tweezers holding it in place. You probably want to get your tweezers on there first, because you you want to not like, burn up the flux that's inside the solder. All right, from there, now do pins 2 and 3 because they'll be easier. All right, don't do it with this, with those. All right, good. All right, that's good. Okay. Now, yeah, so now when you do it, let's have you hold the pin with the tweezers as you flow it. Yep.
So
yep. Now you want to get down at the bottom and not be, you don't want to do this like, quote Eric, who may or may not have actually been the one that was doing this. But you want to get the bottom pad and flow it up from the pad. You want to flow, you can add more flux if you are having trouble getting it to flow where you want it to go. Yep. So you want to see that the pad on the bottom, flowing. And, ultimately we'll be able to sort of test continuity, and then you'll know whether or not it's a good joint. That looks pretty good. All right, let's go back.
That feels reasonably solid.
Okay, let's go back and reflow that one to a nice looking joint. Yep, so try to get down on the pad. Good. Good. That's good. All right.
So this pin, I pushed it this way. Should I try to pull it back out, or does the battery?
I think that's okay. There. Good. Good. That one's good.
Okay.
Right now that one will take a little bit more. And this is the power pin. Good. Okay. All right. Now inspection. So again, like if we had taken the time to take the board out, it would be a lot easier to sort of tip it on its side and kind of inspect those joints.
I'm not sure about the third one.
Correct. So they look,
I've
looks
got
good on the
other three look good.
So let's reflow that one from the bottom.
I have connected 3 of these well. The other one you can still see a little bit of copper on, so we got to keep working on it.
Yep. So let's have you reflow that just to make it a good, strong, lasting joint.
Add a bit of flux to it.
Flux is always good.
It's okay.
Okay. That one might have been just a little bit light on the original tinning. So,
yeah, it could be. So take a look at it from the side and see if we got it.
That looks good.
Yeah.
That looks great. I bet it's going to work. Now, we can just, go ahead and put battery in it for testing, but we might want to kind of just take a second just while it's open, especially if we've taken out the board and it's going to be kind of a pain, to go ahead and put this on, continuity testing. And again, this is where the schematic comes in really handy. If you know where those lines are supposed to connect to on the board, you can actually test for continuity to make sure that you're getting that connection that you think you need. For us, we can tell just that pins 2 and 3 should connect to the capacitors down there.
Okay. So
and then pin, I forget if it's 1 or 4 is ground. And then the other one should connect to those test points. I think, yep.
Look at that.
Yes.
Okay. And then this is going to be one of these center capacitors, and we're just not sure which one.
It should connect to the top of the capacitor that's at the bottom of that row of 4.
That one?
Yeah, that. Okay, good.
And it's not going to connect on the other side of the capacitor because it's a
right,
capacitor.
Exactly.
All right, so I have successfully, we think, put a new battery connector on there. We have the old battery that's dead as doornails. This is the OEM Apple battery, but we don't really trust it, so we're going to use a new iFixit battery, throw it in here.
Yep. Now let's see if that, now batteries usually come with a little bit of charge in them, so let's just sort of test. We're going to put this back on the voltage V with the line through it for a DC. We'll put it on 20 because we're expecting it to be, somewhere around, hopefully 3.8.
What does it say? Hey,
4.01. So that's going to be, a charged up battery.
Where this battery was reading 0 volts, that's reading 4.0. Fantastic. Right. Okay, so let's connect this thing on.
Right, now be careful of the connector, be gentle with it, because remember, we didn't connect the anchor points.
That's true.
And so, you know, if we can test it, that's fine. But later we would want to come back and, you know, clean it up and put a little bit of adhesive.
I'm not sure. Okay.
That sounded good.
You can see it's a little bit crooked. I didn't get it completely straight on there, but that's okay.
That's okay.
So
Now, for the moment of truth. Now, this phone before could not power off battery. The moment you pulled out the charger, it would come off. So let's see what happens. I see an apple. But
Look at
let's
that.
make sure that it boots up. And
It's on.
more importantly, with the battery connector job, I want to make sure that it doesn't boot loop because it can't get
so we wanna make
gas,
sure that it boots
gas
all
and
the way.
temperature information. Exactly.
Okay.
Yeah. There you go.
iPhone.
iPhone. Yay!
That's exciting.
That's right. So now this phone is ready for us to use in our water damage video.
Okay. So what we have done here was we took a phone that was plugging, when you plugged it in, it worked fine. Everything
Right.
on it was okay. The moment you disconnected the power,
It couldn't talk to the
shut off.
battery.
It couldn't talk to the battery.
Right.
So we knew there was some kind of connectivity problem with the battery. We tested the battery, and the battery was dead.
Right.
So we're like, okay, well, we have to investigate the charge port, take a look at the charge port, and it's clear that there's been a previous repair or there's some kind of physical damage
Right.
to the charge port. So we got a
To
new
the battery connector. Yes.
right, to the battery connector inside
Right.
the. Okay, so we put on a new battery connector.
Yep.
And we were able to test for continuity on either side of it. Put a new battery in. We'll test the new battery. We know the battery is good. Put it in the phone, and it works.
Yep. Learned about the multimeter and learned about how paying attention to thermal mass really helps you when you're starting
It really
out.
does make a big difference.
It
The
does.
amount of heat that you apply, you have
Right.
to heat those other pens for much longer than the
Right.
center
I mean,
pens.
one of the most common problems that a beginning microsolderer is going to face is pulling off pads. And then, you know, that really stinks because you can ruin a device, you know. So
that's mostly going to be caused by not heating it enough, yanking it off too quickly.
by assuming that if you see liquid flow on one pad that they're all ready and then you rip it off too soon.
And that was challenging. It was challenging to get all four at
Right.
the same time. So I ended up kind of tearing the old connector apart in the
Right.
process of getting it off.
Right.
But I think that was better than applying too much force and ripping it
Right.
off.
Yep. And low melt can help, you know, if you're
Okay.
struggling. Yep.
Fantastic. Well, this has been hugely informative,
All right.
and I'm excited to continue along my journey, learning about how to repair these things at the very small level. The next video that we're going to be investigating water damage. So
Yes.
that will be very
that's,
excited.
That's huge. Yeah. Water damage. Yep.
So thanks so much for following along. I'm Kyle with iFixit. Subscribe to the channel for updates, and we're going to keep posting more awesome microsoldering repair. I can't tell you how good I feel about myself right now. I've never done anything about this before. I've never done anything like this before.
Yeah.
This is
Now
really,
you're
really
two for
exciting.
two.
Thanks
Well
a lot,
done.
Jessa. All right.